According to this question, if A is a 3 cross 3 non-zero matrix such that A squared is equals to 0, that is the null matrix, then the determinant of this expression is what? So clearly you can see that there are matrices and determinants involved. So I would write the topic for this question will be matrices and determinants. Also along with that, you see this I plus A to the power 50. To solve these kind of things, we need to use the concept of binomial theorem 2. Now binomial theorem can be applied to matrices only if they are commutative in nature. What do you mean by commutative in nature? So if I have a matrix A and if I have a matrix B, then A plus B should be equals to B plus A. If this condition is satisfied, only then you can apply the binomial theorem to this kind of matrices. So let's revisit what the binomial theorem is, and then we will solve this problem. So if you have an expression of this form, x plus y to the power n, where x and y are real numbers, then we have the expression for this as n choose 0. Here by this n choose r, I mean NCR. Some of you might be habituated with this notation, and the value for this is n factorial divided by r factorial into n minus r factorial. So this is equals to NCR x to the power n and y power 0, n choose 1, x power n minus 1, y, n choose 2, x power n minus 2, y square, and this goes on till n choose n, x power n minus n, and y power n. So if I write the general term for this expression, it can be written in this form also. X plus y to the power n is the summation from r equals to 0 to n choose r, x to the power n minus r, y to the power r. So this is what the binomial theorem used to be. Now let's solve this question. Let me clear out the working area. Okay, so what we have over here is we need to find out the determinant of I plus A to the power 50 minus 50 times A. So let's find what the value of this is. So determinant of I plus A to the power 50, this will be 50 choose 0, I to the power 50 and A to the power 0, that is I itself, that is the identity matrix itself. So we are going to leave that alone, plus 50 choose 1, I to the power 49 and A here, plus 50 choose 2, I to the power 48 A square, and it will go on till the last term, that is 50 choose 50, I to the power 0 and A to the power 50. And we have this minus 50A over here, so we are going to include that also, minus 50A. So this turns out to be determinant of 50 choose 0 is 1, so this is I to the power 50 only. And if you remember, then power of anything of an identity matrix is the identity matrix itself. So instead of writing I to the power 50, I can simply write I over here So this is I. 50 choose 1 is 50, and I into any matrix is that matrix itself. That's why it's the identity matrix. Then we have the rest of the terms, that is 50 choose 2 a square, then we will have 50 choose 3 a cube, and it will go on till 50 choose 50 a to the power 50 minus 50a. You see this minus 50a and here a plus 50a, these two gets cancelled. Now when these two gets cancelled, what we have is determinant of I plus determinant of this matrix, that is 50 choose 2 a square. Then we will have the determinant of this matrix, that is 50 choose 3 a cube, and so on. Till the last term, that is determinant of 50 choose 50 a to the power 50. Now a square is 0, so determinant of this will be 0. Similarly, a cube can be written as a square times a, and that is nothing but 0. So this will also become 0, and all the other subsequent terms will be 0. So what we are left with is determinant of I, and determinant of I is equals to 1. So the answer to this question will be